Discussing how to create a machine learning model to identify fake news. Fake news is simply false rumors or supposed facts that are spread about some event, and fake news as current is currently on a rise. As before, there were only a few printing presses which had to be monitored to prevent the spread of fake news. Now, due to social media, there are many platforms where fake news can be spread without being monitored, as you cannot monitor the whole web. So mainly though, fake news is spread through social media platforms, and due to the current rise of COVID 19, there's been a lot of fake news related to COVID 19, and there has been an overall rise in this trend of fake news. So, to deal, why is it so important to deal with fake news? It is important to deal with fake news because, as you can see, fake news is causing a lot of problems. First of all, people being misinformed can take precautions which they supposedly think will protect them or which they think are right, and these actions are based on false knowledge. So that's why it said beware of false knowledge, as it is more dangerous than ignorance, because people who have little idea about things try to uh, for example, if fake news was spread related to some stock, right? So what would happen is someone would invest in that stock if some fake news spread that it's supposedly going to increase by 300% and Warren Buffett has invested in it. This fake news would cause many people to go and also purchase that stock, which was never going to rise in the first place, thus wasting their money, time, effort, after all just because of one fake news article which was forwarded on WhatsApp by someone they know. So, how can we battle or um, check whether the news is fake or not? So on the screen there are 4 steps which you can use to verify whether the news is fake or not yourself. But thing is, for every piece of news you find, you cannot go through all 4 of these steps. It will become way too lengthy. Every time you cannot be expected to do all of that, because then reading the news is going to become a headache for everyone if they have to do that much research, and that also for just believing one article. People would just rather be uninformed rather than do all of that, because people don't have the time to go through those 4 steps for every single article they read online or is forwarded to them. So we need to create an autonomous machine learning model which can execute these 4 steps by itself without any initiation or initiation from the consumers. It should be able to monitor the web by itself and remove all the and flag all the fake articles so that they can be removed by doing these 4 steps. So presently, fake news is removed manually. So either of these 3 things that are highlighted here happen: either the employees who are hired by the company find it, governments or consumers report it. But this has a lot of challenges, because after all, these every entity here is a human, so human error, plus humans are not that fast. So this method is good, but it doesn't have that high in accuracy, neither the speed. So the current way had to be replaced, was evident, and the challenges that we face with the current way are many, right? Because being humans, there is too much data, we don't have time, we need too many people, and then also there is a human error, because are quite humans are susceptible to making errors. So, due to these challenges, it was clear that this solution was not a long lasting one. And thankfully, machine learning is the solution to solving these challenges and this problem in a much better manner than is currently being used. So the technical aspects are, there are many machine learning models and vectorizers which have been used over time to deal with this problem. There was bag of words, there is TF-IDF, there was for the machine learning algorithm, there was logistic regression, then there was random forest, now there's passive aggressive, and after this also there is BERT. So over time, the process is constantly evolving. But here I have given why we'll be using TF, IDF, and passive aggressive classifier instead of the standard bag of words and logistic regression, and why we are doing that, because both bag of words and logistic regression have some problems which are addressed via TF, IDF, and passive aggressive, and then TF, IDF, and passive aggressive have some problems which are then further addressed by word2vec and BERT. BERT is a very recent model released in 2021. We will make a video on that too. We will, in a future video, we will approach that topic. So the methodology, or how we have planned to deal with the problem, is simple. We are going to get a mixture of real and fake data, which will be randomly assigned into training and testing sets, feed it to the TF-IDF vectorizer, which will convert our words into numbers, give it to the passive aggressive classifier. The reason we are running 50 iterations is because 50 is considered the number from where on your statistical value will start becoming really significant. So usually it's above 50 that people would like, even data should be at least above 50 records. That's the least. It should be much more than that. The more the better, but at least 50 before you can give any significance to the statistical values like mean, mode, median. You need at least 50. The accuracy score we are expecting is 90 to 92%. There are other models which can give you better accuracy scores like BERT, but this model you can expect 90 to 92%. This is how the TF IDF vectorizer works, right? So these above two statements A and B are both true statements, and the way it's dealing with them is it takes the number of times the word is present in the statement divided by the number of words in the statement. That's term frequency, the amount of times the term was frequented in the statement, followed by inverse document frequency, which then checks out of how many sentences was, like how many total sentences were there, and in how divided by how many statements had that word present in it. So number of document, so it's simply number of total statements upon number of statements the word appeared in, and then we multiply TF with IDF to get our values, which are simply saying, which words are important. Like is has literally no importance, no importance. We're using this to get our main keywords, which here are Jupiter, largest planet, Mars, fourth from Sun. So, and one more thing is, the way this works is, for example, if you had a false statement, right? Jupiter is the smallest planet, or Jupiter is not the largest planet. Now, for example, Jupiter is the smallest planet. What would happen is, the keywords that will be taken will be Jupiter, smallest, and planet from that statement. Is and the would be removed. Now, Jupiter, largest planet, would do this, that it would, there are keywords assigned with Jupiter. Now, planet is a keyword that will always appear with any article in which Jupiter is present, because it's a planet. Largest has appeared, but smallest has never appeared as a keyword with Jupiter. So that will immediately ring some alarms, and that news will be flagged as fake news and removed from the web immediately. How does passive aggressive classifier work, or why are we using passive aggressive classifier? We are using passive aggressive classifier because it's an online machine learning algorithm. It can constantly monitor data and deal with it constantly while adjusting weights. So it's reinforcement learning. It's making changes as it's learning, as it's monitoring. It does not require all the data to be given to it at once, and then you have to yourself give it the data again and again. No, it can take its data by itself, spread it in subsections where it can deal with it fast, because online you need to deal with the fake news quick before it spreads, right? It quickly has to be removed, flagged, otherwise people will keep forwarding and reading it, and that fake knowledge will be spread all around. So this is how passive aggressive classifier works, and the reasons we are using it are because it is faster, it is completely autonomous, almost completely, and it is quick in making predictions and dealing with them. And this, so now begins the programming part. So there are some steps. First, mainly is data acquisition, where you get all your tools, which are your machine learning uh, libraries that you require for creating a model. NumPy, Pandas, everything, right? NumPy, Pandas you use for handling your data, and there is confusion matrix and accuracy score, which you use to analyze how good your machine learning model is doing. To read the data, you will have to give it the file path. For Windows and Mac, it differs. This is file path for Windows. For Mac, you will have to go and do. You can search online. There's a different way to get the file path. But for Windows, the file path usually looks like this. Data preparation is simply when we are preparing the data so that the machine learning model can simply be able to use it correctly. So like what train, test, split, you get the labels separated, all that. This is a very essential step. Test size, we are using 20%, but you can even keep it like 30%, 40%. We are keeping it 20% as of now because we want more training data, as this is going to be a large model. We are going to have so many news articles, so we want more training data so that our machine can get used to handling all of those. This because news will be there will be a lot of news on every subject. Now the machine learning algorithm needs to be able to get at least 50 or 60 examples of every topic to be able to deal with the other news articles by itself. So that's why we're leaving a comparatively low amount for test size and a much larger training set. Data pre-processing. So this is mainly where we are going to implement TF-IDF vectorizer on our data so that we can get the keywords from our news articles, and then we're going to do this on both train and test, obviously, because only by getting the keywords is our machine learning model going to be able to understand which words, whether it is fake news or not. And here there's a certain command, stop words English is equals English. This is stop words are simply words which do not have which do not have any importance or effect on the data, because we are only taking keywords. So for example, the statement which we had seen previously, which was Jupiter is the largest planet, is and there were eliminated. But that was because they were stop words. Now they were also eliminated through TF-IDF, but they would be eliminated much before via stop words, and then TF-IDF would kick into action and eliminate any further words which are not used, like and as a stop word, so it would be removed. Model creation. So here we are initializing our model and fitting it on our data and getting our predictions uh, and our accuracy score. So we are this will take a while because you are using there's a good amount of data here, so our passive aggressive classifier will take a while to be fit, but it shouldn't take very long. Finally, we'll be building a confusion matrix, so which will simply give you true positives, negatives, false positives, and negatives. And I've explained what they are on the slide, so you can read it from there itself. And in the confusion matrix, I'm using Seaborn instead of Matplotlib because Seaborn is a much better visualization tool while compared to Matplotlib. Its visualizations look cleaner, better, and it overall gives you more freedom, more you can make your visualizations look much better, more artistic, graphically, visually pleasing. For example, here I've used annot equals true. This is simply giving annotations so that we can understand what our values are. And I'm CMAP equals blue, so I'm programming it so that the confusion matrix, the color huing, which is based on whether the accuracy scores, is based on blue colors rather than just the normal colors that we would be given by Matplotlib. So, in summary, the fake news detection project dealt with most of the problems that we had previously. Yes, there is still some, I mean, it has dealt with most of the problems. You can see which passive aggressive classifier and TF-IDF have dealt with which problems individually. And but regardless, there are some improvements possible in the futures, and you can see that even despite 92% being a good accuracy, it's still leaving 4 million fake news unattended, which is still a pretty big number. So of course, I mentioned before there is BERT model which can correctly classify 98%. We will cover it in a future video, along with web scraping and word2vec. Reason I'm talking about web scraping, I've talked about web scraping a lot in this video. Web scraping simply pulls data from the web related to whatever subject you require it to, and word2vec is one of the few word text vectorization uh, uh, modules available which can actually understand or get a good idea of the semantic meaning, logical meaning that lies behind the words, and uh, make it, transform it into such numerical vectors that even the machine can get an idea of the semantic meaning or relativity between the words. So that is all for this video.